Okay, so today we're going to go through Docker as a container manager. Now, Docker has been around outside of academia, outside of advanced research computing for some time now. But now that we're working with clouds more and more often, and more people want to make their research more interactive, the tools that are available generally outside of academia are becoming more and more popular inside of academia. A major motivator that I had while making this, or for making this presentation, was singularity. So Docker is not traditionally an HPC, a high-performance computing tool. Singularity is your answer when working in a cluster environment. However, almost all of the instructions I've read on Singularity start with, it's like Docker, but. So if you don't know Docker, it's going to be hard to figure out how to use other tools. So without further ado, we're going to move on with the presentation. This is going to be in two parts. First, I'm going to go through some slides just to make sure I hit all of the basics of the commands in Docker and kind of show you what a container is. And then we'll move to the command line and I'll run through some instructions live, and hopefully everything goes well. So, Docker. So a core aspect of Docker, or the purpose of Docker, is to run software packages inside of isolated containers. Now, these containers will be separate from your machine environment. So traditionally, instead of building one app or multiple apps on one machine and porting it to another, you can run it in containers and solve many of the porting problems. The whole idea being, if it runs in a container somewhere, it should run in a container somewhere else without alteration. Another thing you can do with this is it'll allow you to run multiple projects at the same time. The more and more projects, the more and more software packages you run at once, the more likely you're going to have conflicts. If each package is run within its own container and then communicates as if they were separate machines, many fewer conflicts, less packages that are going to run into each other. And a major thing I think that would be helpful in the advanced research computing or HPC environment is the ability to quickly set up your tools and dependencies of your project. As more and more computing goes to the cloud, you might be moving around, you might be starting your cloud up, shutting it down, and you'll want to be able to get your tool chain up and running quickly. Or if you get a new research assistant in, or you are a new research assistant, if they can hand you a Dockerfile that says, okay, now set this up in your computer, away you go, it's a lot easier than learning how to set up all of these software packages. As more and more often I'm finding that the researchers are experts in their domain, and then computers are kind of a side effect. But of course, the computers are more and more needed to do the research in your domain. So that's kind of the motivation for what's going on at Docker, why we're talking about Docker. But of course, what is Docker? So a lot of people are familiar with the more traditional virtual machine setup. So a virtual machine will run, so a single or multiple virtual machines will run within a hardware setup. So you have your hardware layer. Your hardware will be running a host operating system with its own kernel, and then it runs what's called a hypervisor that will manage virtual machines, many virtual machines on one piece of hardware. And this is what most people would consider a cloud computing environment. Each virtual machine has its own operating system, its own file system, and its own kernel, and has its own individual dependencies and applications. Now, these typically take a bit of time to boot up, to get running. An alternative to virtual machines in solving some of the same problems, but less heavyweight, is containers. So a container still runs on hardware. It still runs on a host OS with its own kernel, but each container doesn't have its own kernel. It's much more lightweight and starts up much quicker. And you can run multiple containers on the machine. Typically, you'll actually run multiple containers, one or more, on a virtual machine. So you'll spin up your virtual machine, then you'll spin up a container within that, and it's much easier to get up and running that way. Containers have their own isolated file systems, and most importantly, their own isolated dependencies. And that means that each container can run its own software package without conflicting with the other ones. As a result of not having a shared kernel as opposed to their own kernels, and being lightweight, it takes a lot less disk space and memory and boots up in seconds as opposed to minutes. So what we're going to run into now, I'm going to go through the slides of just some of the common commands. We're not going to cover how to install Docker because it's actually quite trivial. You can install it on Windows, you can install it on Mac. Linux is most often its environment that you'll install it in. You can install it on our clouds. As a caveat, however, it's best if you install it on Windows in Windows Pro, and it will move most smoothly. After you've installed it, the very first thing you're going to run is docker run hello world. Now we're jumping ahead with the run, but what will happen is you'll get this output. It says unable to find an image, hello world locally. So in order to speed up running Dockers, it will cache images from a remote host to your local host, so that the next time you run it, it doesn't have to do the download every time. But because it's not, it'll say we're pulling the library hello world. Pull is complete. It gives you a little bit of a hash key. Tells you what's going on. And this down here is the output. So what happens is your Docker daemon, which does the management for the containers, will pull the image. It will run the image and then output the image to the, not output the image, output the standard out to your terminal. And then it terminates the image. These images typically are used to run something and stop, or to run a web server and forget. So if it runs something and once the program's done running, the image itself, the container, will exit. So you don't always necessarily want to run something right away. With the Docker pull hello world will pull the image in a much similar way to Docker run pulls and runs it. It just skips the run step. And of particular note here is the lack of output at the bottom. Not much new with pull. If you're familiar with GitHub, it's a very similar setup. And what I'm going to mention now is when I do pull, it's actually pulling from Docker Hub, which we'll cover in a minute. You can set it up to pull from a local repository, though probably wouldn't in a research group situation. If you're familiar with a GitHub setup, you'll be familiar with a Docker Hub setup. It's the same idea, whereas GitHub's for more text or code-based, the Docker Hub is for image-based or large files, like binaries. We can also list the containers. So Docker PS and Docker PS-A. What this is doing, Docker PS will show your running containers. You'll get a container ID. You'll get what image you're running. So in this case, it's running Debian. It's just running the Debian environment. What command was used to start it? Bash is always one command to start it. When it was started and how long it's been up and running. When I took this screenshot, I guess I took it almost immediately after I started it. PS-A is a little different. You actually use it probably more often than PS. And that will show you images that have stopped. And so in this case, you'll see here it says exited. That means that the hello world ran and exited 13 seconds ago. As a side note, Docker PS is the old way of doing things. They have recently changed the way you do the commands for the Docker container PS you might see in some places, which is the same thing. It's just they've mapped the commands to make it a bit more clear what's going on, because there's also Docker image commands. So Docker images will show what images you have downloaded. In this case, if we run hello world, it will only be one image, hello world. It'll show you the tag, which one it is, because there's multiple possible images for each one, image ID, when it was created, and how much space it's taking. You'll want to remove images, and that's Docker RMI, stands for remove image. And you'll put in the image ID. When you do this, you don't necessarily, and every time you see an ID, you don't have to put in the full ID, you just have to put in enough that differentiates. So I could do RMI FCE, and it would know what image I'm talking about to remove it. And in reality, this image ID that it shows up is really just the start. If you take a look back here, well, I guess it didn't show it there. It's just the start of the image ID. So we got Docker images, Docker RMI to remove an image. If your image is in use, even if it's stopped, it won't let you remove an image without deleting the container. If it's a non-running stop container, you can add a -f -f to the RMI in order to force the container to stop, delete, and then remove the image. What you'll be using, this is the important command, I guess you'd say, the central command is Docker run. Now, Docker run will download, if it's not available, an image, or it'll run a Docker file, a Docker image that you've made from a Docker file locally. So we're going to spend a little bit of time looking at some of the commands I'm going to cover. Docker, as a side note, has a very good documentation. So if you go to that link, it will show you the command lines for run, or all the commands. We're just touching on a few of them here, the most common ones. And it's also got really good documentation for Dockerfile, so there's no reason to really recreate it anywhere. Some packages, you'll note, aren't necessarily documented very well. Docker is not one of those. So some of the flags, these options: Docker run. Docker is the name of the program, obviously. Run is the Docker command that we're calling. So Docker, and then Docker command, so Docker run. And then you put in the flags for run. Now the ones we're going to look at here is you'll see -I for interactive. That'll keep standard in open even if it's not currently attached. -T allocates a TTY terminal. Not going to go too much detail into that, but you almost always just do a -IT, and then a D, the detach. So if it's not attached, it's detached. It'll run your container in the background and give you a container ID. So it won't print the output to standard out anymore. And these are the kind of things you'll use if you want to run a web server or a persistently running package. That way you have the terminal open, you can shut down your terminal, it should still be running, and you can do other things in your terminal. It's not being taken up by Docker. I will often use --rm, and that means that when I'm done with the Docker, it'll automatically remove it. So when you run an image or a container, the container will stick around. Often the case is you don't want it to stick around, so you can use --rm just to clear it out right away. And if you don't want to use the ID, or you don't want to have to look up the ID every time, you can use --name to give a reference name to your image. So you can always, whenever you remove the image or you stop or start the image, the container, sorry, not the image, you can refer to it by its name. Then you put in the image name, so you got Docker run -itd -rm -name, your name, the name of the image you want to run, in this case Ubuntu, and then an optional argument can be put at the end, and I'll show you that's particularly relevant. That'll be the first argument running when you run the image. So a persistent container, as opposed to the hello world as a temporary container, is Ubuntu. And this will just run. So this is your ID that I was talking about earlier. It'll show you you just need to refer to the first couple of letters when referring to it. Unable to find the image locally, runs it, so on and so forth. Now this will be running persistently until you stop it, as that's what the Ubuntu image does. So when you're running that image, some of the things you're going to want to do is you're going to want to be able to stop it. So we're just going to run through a bunch of commands real quick here. To stop a running image, it's stop. Just Docker stop the image name or the ID. If you got a running detached image, a persistent one just running, you can exec to run a command into the running image, and that is Docker exec. Go -IT to set up the stuff. You do your ID or the name, and then the command. In this case, if you go bin bash, you'll actually log in to the image, and you'll be able to run it and look at things, what's going on, and we'll show you that in a minute. So we'll run a Linux image on Windows, log in, and you'll see it's Linux instead of Windows. So that actually logs into the container. If you want to check in an image, so this is if you've got a Docker Hub account, you do Docker push. It'll be your username and the image name. You can log into, before you can check in an image, you have to log into Docker Hub. Docker login minus your username. It'll prompt you for a password, or you can set up for your, you can read the instructions on the website for how to set up without prompting the password. And of course, log out of Docker Hub with Docker logout. So as a bit of a review, we just kind of went over, what's going on here is we're going to build a custom image with a Dockerfile. Now, a Dockerfile is a set of instructions or steps to perform in order to build an image. You declare the operating system, you declare what supporting software, and then you copy your application and any documents relevant into the image. And you'll use Docker build to do this. And that will build you an image, and then you use Docker run to run it into a container. So this is just kind of, I guess, the environment or the language we'll be using. So Dockerfile to build into an image to run into a container. And we'll show you how to do that. So to use Docker build is literally Docker build, options, and path. Now the path is a path to your Docker file. You can either put in the absolute path and the name of the Docker file, or if you put in the directory, it'll automatically just look for a file literally called Dockerfile, capital D, Dockerfile. So you'll typically see the Docker build examples, or when people give you instructions on how to build their image, it'll be Docker build, their options, and then just dot, and it'll look in the current directory for the Docker file. The most common one, or the one you'll see, is the tag option. Log on the website for more options, and this just gives a name for your Docker image, so you can find it when you do Docker images. So Docker Hub. I'm not a proponent for big container, but Docker Hub does provide container storage services for you that you can use at a reasonable price at hub.docker.com, and we'll go take a look at that website. And that is, I guess, how they make their money. You can run your own, you can install your own, but the price points for Docker Hub are actually quite reasonable. And if you use Dropbox or anything like that, repositories, GitHub, it's very similar. For free, you get a private repository, and I do believe as many public repositories as you want. And for $7 a month, you can have 5 private repositories. And then parallel builds, it has to do with automatically building your container, but we're not, or your image, but we're not going to get into that today. So now we're going to move from the slideshow portion, which I like to go through just to make sure that I've actually said all of the relevant information. And we're going to move into the actual demonstration. Now I'm running this in Windows PowerShell, and I'm also going to do a bit of it in Linux just to kind of show you that Docker commands are completely portable. They're the same in Windows, they're the same in Linux, they're the same in Mac. So here we are, we've got my directory. I'm in Docker Scratch. So the first thing we're going to go through is we're going to go Docker version, just to see what's going on with the Docker. So version 19.035, Go version. Docker's actually written in the Go programming language, get hash when it was built, so on and so forth. So one of the things basically this is what you care about the most is version, just to make sure everything's compatible. You can also go Docker info. So hopefully I've cleaned mine up before we started. So we have no running containers, and no pause, no stop, no images. So everything's just kind of empty right now as if we had first installed it. So Docker, the first thing is we'll go Docker run hello world. And that was the example I showed you earlier. And this is literally what's going on. Now there's a bit more because I couldn't fit it all on the slide. And this is just to make sure that your installation is installed and working correctly. Docker client contacted the Docker daemon, which is running. The Docker daemon pulled hello world from Docker Hub, the default repository, created a new container automatically from that image, and then runs the executable that it was told to run. Docker daemon then streamed that output to your client, which is this terminal, and so on and so forth. Now it gives you a bit more information you can go look up on your own. Ubuntu, so on and so forth, and we are actually going to run a Tomcat image. Now, Tomcat is a browser, not a browser, it is a server for web pages. Docker run Tomcat. Now, this, coincidentally, and I'm doing this quite deliberately, isn't going to work because there's a couple more flags that we need to include when we run in order to show you, in order to get things working. That's basically, we're going to need to point the ports. We need to tell Docker what ports we intend it to point its web server at. It's actually a pretty quick download. Note that you only have to go through this, the download or the pulls once, because it'll cache them locally. Where's my pointer? There we go. So now we're going to go into my browser, and we are going to go to localhost 8080, which is Tomcat, and it seems to be running. Why is it running? Oh well. Oh, there we go. Cache page. That's why. So it's not running. And the reason for that is I didn't tell it what port to run on. So we're just going to fix it. We're going to Control-C. Stop it. Clear. We are going to go Docker PS. It's still running. So we're going to go Docker stop. Now note, I'm just going to go CD9, which is the first couple of letters here at the beginning of the container ID, and it will stop it. And we are going to simply run it again, but this time we are going to go -P for port, and it'll be the local port, 8080. We want to point towards 8080, and the container port. So the container 8080 is going to point at the local 8080. And we'll run that again. Now, note that this is not detached, so all the output is going to our screen or going to our terminal, and that's what all this gobbledygook is. And we're going to go take a look, and we will refresh this page. There we go. Now Apache Tomcat is running. And it's as simple as that to get a web server up and running. However, so we're going to go take a look at what we just got here. So this is Tomcat. We're going to go to Docker Hub. And we're going to see what Tomcat is. So Tomcat is, we're just going to search it. Tomcat, there it is. 10 million plus downloads, 2.6 thousand stars, so we probably got the right one. And now these are all the different tags. So you can specify which one you want, many different versions. Tomcat keeps it up. We're just going to take the top one. And we're going to look at this, what shows up here. So what's going on? Let me increase the screen size. This is the Docker file that is used to build the Tomcat image. Here, all Docker files have a from, and it tells you what this image is based on. So it's based on the JDK Oracle image, which in turn will be based on something else. It's based on something else. So it kind of builds up in layers. Environment variable. You can set an environment variable the same as you would in Linux normally. So these just set those up. Run, the run command, as opposed to at the very bottom, you'll see the CMD. Run runs the command while building your image, as opposed to CMD, which runs the command when you start the image. You can only have one CMD. So when we start up the container with the Tomcat image, it simply runs catalina.sh with the argument run, which if you're familiar with Tomcat, just starts the server. If you were to load it manually onto your Ubuntu image, this is what you'd have to type into the command line to start it. You'll see there's many runs. We won't go into detail what's going on here, but these are all runs to set up the image for you. It's just interesting to look at, and sometimes you need to go in there to find out typically what an environment variable is, where something is. So like we want to know user local Tomcat is the Catalina home, which is where we're going to put the web pages. So let's go back to our terminal. We are going to stop this. And of course, we have to go Docker PS, Docker stop 430, oops, not 420, 430, Docker PS -A to show it all. Now we've got a bunch sitting here. Now we want to remove, and this is kind of a side note, we want to remove the old images or the old containers we're not going to use again. You can start them up again. You can go Docker start 430, it'll start up. You have to stop it again. But often, especially when you're developing these containers, you want them to stop and disappear. And to do that, it's docker rm the image ID. So docker ps minus a, you notice we only have 2. Now to get rid of, now this is a handy little command, to get rid of, you can go docker ps minus aq, which will show you just the image IDs. So that you can go docker rm and use a little bit of a bash command to go docker ps minus aq, and it will feed these image IDs into docker rm and in effect remove all your image, all the containers. So we go ps minus a, they should all be gone. And that's just a quick little thing, so we don't have to type them each in individually. Increase my screen to names, the S is on the next line. Okay, so moving on. What we're going to do now is I'm going to run my Tomcat again, docker run, but this time I'm going to go minus itd, so it will run detached, minus rm, and it will remove itself when I stop it. Set up the port, as we learned we need on the 8080, pointing to 8080, and Tomcat. So there we go. Now it's running in the background. We still have our terminal. Just to show you that it's running. There she is. What we're going to do here is we are going to, I've got a page here in this directory, an index.html, a very typical web page, very simple. And it's just says hello world web page. And we want to run that or move that into our Tomcat running image. So we're going to use docker cp for copy. Let's go back to our root. Docker cp my web index.html into the container ID, which I don't know what it is, so we're going to go docker ps first. Container ID. So docker cp /web slash my web. That's why. There we go. Index space ID. So we'll go E58. Let's differentiate it. That's the first little ID bit there. The container name. And now we're going to go for the target of what directory we want to put it into. So user/local/tomcat, which we saw that's Catalina home we saw from the Dockerfile. Web apps, which is just inside Catalina home where your web applications are, and root, which means it's the root image or the root web page. So there we go, we move that in. Let's see if she worked. There we go. Hello world, this is my website on Tomcat. What I'm going to do is I'm going to log into the container. We're just going to have a little look around, and then we're going to do this in a slightly less tedious manner. So if you've got a running image, so I've got docker ps, we know it's running, status, about a minute, it's still up. We want to go in and do something manually. So if you go docker exec, means the execute command, execute a command on the docker, minus it, and then the docker image name, so E58 is who we are today. And then the command we're going to run. Now you can go ls, that's a command. So here we are, that's the, of note, this is the root directory is actually the working directory. So if we go take a look at this again, so working directory was set in the Dockerfile. So that'll be the default directory whenever you run anything on the image. Whereas you might think the default directory when you log into a shell on the cluster is your home directory, or the root directory if you were just running it on yourself, on your own computer. It's the work directory is set by the Dockerfile. You might want to go in and look at that. So there we are. It's the, if we want to see what's going on in ls, but we're actually going to go and we're going to go /bin/bash, and we're going to log in. So we're now logged into the cluster. And we're going to go into the web apps directory. You'll see this is the web apps. Root is where we put our page. There it is. It's index.html. I don't think we have Vim, do we? Nope. So we're just going to cat index.html just to show you that. So if we want to change that, we could change it here. We'd have to install Vim. We'd have to either or copy it back in, and that's tedious. So what we're going to do instead, we're going to exit back out to where we were. We're going to stop it. So Docker, what is my Docker? PS, we are E58. Docker stop E58. And just to show you, Docker PS minus A is no longer running. So that's because we put the -- rm to remove it when we were done. So show you the Dockerfile. So as a note, it's Docker copy source. I'm just going to put this here to save me. So when we did the copy, it's Docker copy and then source and then destination. You can also reverse that if you use the SCP. You can copy files from your container back to your desktop. So now we are going to go and we are going to do a Docker file. So I've got a Docker file here in my root directory. What we've got here, and I'm going to open it up in Kate just so we can, there's my instructions that I'm following, see it a bit better. So we've got only 3 things here. We've got from, so Tomcat latest. So we are going to make our own image with instructions, but we're going to base it on the Tomcat image that we just made, or we just used. We're going to run rm minus rf, so we're going to run the Linux command remove, recursive and forced, the Catalina home, which is set in the Docker file up here that we saw earlier. So there is an environment variable called Catalina home, and we're going to remove all the directories in web apps. And then we're going to copy my web, so it's going to copy the contents of that directory into the root. And that way, it just is a different way of doing what we did manually a second ago, but instead we're going to do it as in we're building an image. So let's see what that, this is Docker build. And this is a trivial Docker build file, obviously, but it's for demonstrations. Let me get my notes back up to where they belong. So Docker build, that's the command. We are going to give it a tag. We're going to call it my Tomcat. And that's just so that it's easier to find. And then the location of the Docker file, you could go /Dockerfile, but you don't have to. It'll automatically look for something called Dockerfile, note capital D, in the directory you provide. So let's build, sending the build context to Docker daemon, and then the little steps, what it's doing. There is a note here, because we are going in Windows and we are building an Ubuntu image, there are some file permission issues. And any files and directories that you make will be given public read, write, execute, and read, and then, or sorry, public read, execute permissions. So you might want to go in and check that. But we're not too concerned about that. Not right now anyways. So Docker images to see what we just built. So there we go. We got the my Tomcat that we just built, Tomcat and Hello World that we downloaded earlier. So now that we have built the my Tomcat image, we can run the my Tomcat image. Docker run in the same way as before. We're actually going to give it a name just for demonstration purposes. My website -itd, so that it detaches and keeps all the terminal important stuff. --rm, so it deletes when we stop it. Don't forget to set up port because it's still a Tomcat image, just with some changes. And then we're going to call it my Tomcat. Sorry, we're not going to call it my Tomcat. We're going to run the my Tomcat image. That's the last command here. So there we go. Up and running. Docker PS. So you'll see that. Now this time, we have a name, my website. And we can refer to it with that. So let's go take a look at 8080 again. And hopefully it's exactly the same because we just copied it in. However, we'll go take a look at the image. So Docker PS. So we'll go Docker exec -it, the image name. Now we can call it, I think I called it my website. My website. Instead of using the ID hash that it gives you. Docker exec my website /bin/bash. Now we've logged into it again, calling web apps, and we're just taking a look to see what we did. So in the Docker file, we deleted all of the default web applications that Tomcat comes with, and we replaced root with just the one file, index.html. And that just kind of shows you that what you do on the image creation is now it's repeatable. Now anytime we want to start with a fresh image, so we can stop this, we can put a file here, we'll touch a file. So there's a file here, we'll exit. Docker, oh, I forgot something, stop, it'll remove. Docker stop my website. Docker stops. Docker ps-a, it's gone. If we run it again, Docker run, and we exec into it. Go into web apps. It's gone. And that's because we rebuilt it. We reran the container. If we were to stop it and then start it again, anything we create is still there. Hopefully that's clear. I can go into more detail at request, I suppose, but we need to move on. So we'll stop that again. Docker stop my name. My website is now stopped. What we are going to do is I'm just going to show you, and we are going to go into a Debian image to build a Docker image that we're going to pull back to Windows. So SSH Docker. Docker is just the name of the server I've got up and running on our cloud. Oh yeah. So note, particularly when in Linux, you have to do everything as root when you're building these images. And that is why you can't run these on the cluster. You can't build images on the cluster, because you have to have root to do this. And that's why we use Singularity. So we'll go into the webinar. There we go. Now notice that the Docker file is the same. It's just Tomcat latest, same kind of stuff. We have the index.html file in a root directory this time. So take note that we copy from the root directory to the web apps root. Same thing. So what we will do is we're going to Docker. Let me remove my images. Docker images, because I've probably done this while getting everything ready. Docker RMI 2b5 Docker images. So there, that's gone before we build it, just to show you that we're building from scratch. Docker build. So we're going to tag it, and the reason I'm tagging this is it's my login name, so this would be your login name for Docker Hub, and then what we want to call the image. And in this case, it's going to be called my website. So it's a little different for the name this time, because we're going to be pushing it to Docker Hub. Build it, because Dockerfile is in the current directory. Doesn't take too long. We're going to go Docker. I think I should still be logged in. Well, maybe not. Docker login -u. Again, this will be your username. Now I'm just going to push my password in from. Okay. Now this is a warning that shows up on Linux, and you can go here. Now it doesn't actually put it unencrypted. It's unencrypted. There's a hash. You can set it up so that you don't have to. If you don't set it up, make sure you log out of Docker every time, because it'll go and delete that file. So now we're now logged into Docker Hub, Docker push, and then the name of the image that we just built refers to the repository, docker.io, my username, and then my website. Now note that this will be a public image. I only have the vanilla Docker Hub account, so you only get one private image. And pushed. Almost. There we go. So now we're going to go over, take a look at Docker Hub, and we should see my image there. There it is. Updated a few seconds ago. So now We will exit Ubuntu or Debian back to my Windows machine. I'm just going to remove the image I made before. Where am I? Oh, I'm still in Debian. We'll go Docker RMI, my Tomcat. So that's deleted. Clear. So that's no longer there. Docker images, just the Tomcat and Hello World one. We are going to go Docker login. My credentials are already in here. Docker pull, my username, again that'll be your username, the name of your image. So the already exists. So that's all the Tomcat and JDK and stuff that we've downloaded already. That's cached. Didn't have to. This is the stuff that it needs to pull. Now that we've pulled it, Docker images, you'll notice it's slightly different. It's no longer my website, but my username and my website. And we are going to run that. So Docker run minus ITD minus RM, set up our port 8080 8080. I suspect you could always put this into a script if you want. Various dot my website. There we go. So now you're not going to see much of a difference, but hopefully it's still running. There you go. Hello world. This is my website. We are going to run the exact same image again, but instead, port is already used and allocated. We're going to change it to port 80. And my point that I'm just trying to show here is that we have the exact same website, but now it's running. So it's actually a different container, and they can run just fine next to each other, one on 80, one on 8080, the two common website ports. Now I'm just going to clean up a bit, and then we will proceed to questions. So Docker images, so Docker, I guess we have to stop the containers first and learn how to spell Docker. Docker PS, Docker RM, I guess we have to stop 873, Docker stop 9, just 9, Docker stop 9, Docker PS minus A, we're all clean. Docker images, now the same as the Docker PS, Docker images minus Q will also give you your Docker image IDs. So we can go Docker RMI, and that will just clear up all of our images. So now everything is cleaned up where we started. So that was the basic introduction to Docker, and honestly, you don't need much more than that to run it. If you're just running root images, you're not doing a Dockerfile, you've got Docker pull and Docker run, and then you could make some changes yourself with Dockerfile. Now take a note, if you've got an image that you run. So if we go, I didn't actually have this in notes, so I got a little bit of time left. If we go Docker run Ubuntu, right? So we're going to run an Ubuntu image as a container. So Docker PS, Docker PS minus A, it ran and exited right away, right? So we're going to Docker run minus ITD Ubuntu Docker PS. It's now up and running and staying there. And I'm going to show you that if we log into it, Docker exec minus IT with the container ID bin bash. There it is. Here we are. We're going to just go into temp, clear. There's nothing in the temp. We're just going to make a file called a file. So now there's something called a file in temp. If we go exit, and because I didn't put the minus RM, we can stop. We can go Docker stop with the container ID. Docker PS minus all. and it still exists there. The 29E9 is still there. And if we go, so what has happened here is we've downloaded Ubuntu, we've created a container from that image, and we stopped the container. So it's not actually running, but our container still exists. It's just not running. So we can start the container again, 29E, and we can log in to the exact same container, go into the temp directory, and that file is still there. So any changes we make to a running container that's then stopped are persistent. And that's the difference between the container and the image. The image is built from the Dockerfile. So let me pull that slide back up, and this is kind of my original point. You've got the Dockerfile, this may make more sense now, builds an image. Image is just a file itself, has all your stuff in it. You run it and create a container. And then you can start and stop the container and make changes to that. If you've messed up your container properly, you can delete it and run a new container, and it's back to where your image was before. So you don't have to worry about breaking stuff. Redundancy is key. Okay, well that is all I've got, and I think we can move on to questions now.